Good morning, children. Today I am going to teach you the chapter 1 of class 9, language of chemistry. In this chapter, basically today we will discuss about the symbols, chemical formula, valency and the formation of chemical formula after knowing the valency. So, first we are going to discuss what is symbol. Symbol is the shorthand representation of an element. Symbol is shorthand representation of an element. Shorthand representation of an element. Like sulfur, the symbol of sulfur is S. Hydrogen, symbol of hydrogen is H. Symbol, generally the one letter symbol are there or two letter symbols are there. Symbols are taken either the first letter of their name. Like sulfur, S, first letter, hydrogen, H, the first letter. Okay, similarly, carbon, C. These all are the single letter symbol. There are two letter symbols also. The two letter symbols are taken from the Latin names of the elements. First letter, first two letters, or first letter or the letter which is pronouncing more in the element. Like sodium. Sodium symbol is Na. Why it is Na? Because Latin name of sodium is natrium and the first two letters taken as a symbol. Potassium. It is not K. Symbol of potassium is not P. It is K. Why? Because the Latin name of potassium is Kalium. Okay? Magnesium. Okay? Observe, it is not the first two letter but M and G, because G is pronouncing more. When we speak maga, then G is pronouncing more. That is why it is taken Mg. So in this way there are one letter symbol or two letter symbols. You have to take care, children, whenever you will write the symbol, if it is single letter symbol, it must be in capital letter, and if it is two letter symbol, then first letter must be capital and second letter should be small. We have to take care. If you will write Na, this will become wrong, or if you will write both capital, this will become wrong. But single letter symbol, it should be capital always, and two letter symbol, then first letter capital and second letter should be small. Okay? Now what does this symbol represent? What meaning we are getting from the symbol? Is it only the shorthand representation? No. It is, yes, it represents the specific element, but with this, it also represents one atom of an element. One atom of an element. Means, if I am writing S here, not only it is representing sulfur, it is also representing one substance means it represents, if we represent a molecule by the help of the symbols, of the atoms present in the molecule, then that representation is called the molecular formula. Like water. Water contains the 2 atoms of hydrogen and 1 atom of oxygen. 1 molecule of water, 2 atoms of hydrogen and 1 atom of oxygen. It is experimentally proved. And if we represent the water by the help of the symbols of the atoms, then the formula we will say H2O. What is H2O? H2O is the chemical, or sometimes it is called the molecular formula of water. So that means what is chemical formula, molecular formula? The representation, symbolic, or in short we can say symbolic representation of one molecule is called the chemical formula. If we are writing CO2, it is the chemical formula of carbon dioxide. What is represent? As I told, the symbol represents 1 atom of the element. Then what informations we are getting from the chemical formula? So number 1, we are getting the information that 1 molecule of this particular substance, or we can say that this particular substance is made up of which element. Like by seeing the formula of water, we are getting the information that water is made up of hydrogen and oxygen. Carbon dioxide is made up of carbon and oxygen. Okay. The second information that chemical formula is giving us, that it is giving us how many number of atoms of each element is present in 1 molecule of that compound. Like by seeing this formula, we are understanding that in 1 molecule of water, 2 hydrogen atom and 1 oxygen atom. In 1 molecule of carbon dioxide, there is 1 carbon atom and 2 oxygen atom. So what information we are getting? First, 1 elements present in the compound. Second information we are getting, that number of atoms of each element in 1 molecule of a compound. This is the 2 basic information we are getting from the molecular formula. So children, in conclusion, if a symbol is written, it is representing 1 atom, and if a chemical formula is written, that means it is representing 1 molecule. Okay. Now after this, we have to understand, I hope you all are clear about the symbol and the formula. Now the next point that we have to understand, that is the concept of valency. Concept of valency. Up to this time, you all learned in junior classes that what is the valency? The combining capacity of an element. combining capacity of an element. It's called the valency. In your junior classes, you have learned this. What do you mean by combining capacity? Combining capacity means the number of hydrogen atom. Children, be careful. The number of hydrogen atom which can be combined directly or indirectly. Directly or indirectly with one atom of any substance. Once again, the number of hydrogen atom which can be combined directly or indirectly. Number of hydrogen atom which can be combined directly or indirectly by an atom. This is the capacity, or we can say this is the combining capacity of an atom. Like, suppose the oxygen is able to combine with 2 hydrogen atoms. So valency is 2. Okay. The carbon is able to combine with 4 hydrogen atoms. 4 hydrogen atoms. Then valency is 4. Okay. So how many hydrogen atom can be combined with an atom? That is called the valency. Okay. Now question you can say, why some atoms can able to combine only 1, some 2, some 3, some 4. So you can understand this when you will learn the atomic structure, valence electron, bonding, that concept, then it will be clear. In this level, you only understand how many hydrogen atoms can be combined with any one atom of the element. That is called the combining capacity of that element. Okay, and the metals valency are represented, the positive one, and the non-metals valency are negative. Means all metals have the positive valencies and all the non-metals have the negative valency. Okay, like sodium, these are metals, +1, potassium valency +1, calcium's valency +2, magnesium's valency +2, okay, aluminium's valency +3, okay, these all are metals. Okay, if you talk about non-metals, carbon -4, oxygen -2, chlorine -1 to non-metals. That means if you are seeing the negative valency of any element, that is the non-metal, and if there is positive valency, that means it is the metal. All metals have positive valency, all non-metals have negative valency. And the molecules are neutral. That means what? The number of the positive metals, positive valency and negative valencies are equal in the compound. Means the molecules are combining in such a way that both the positive and negative valency become equal. Okay, so this is the concept of valency. Now, some metals, there is, you will get the all metals and non-metals valency in the page number 11 of your book. The various metals and non-metals valencies are given there. Where is one more concept? That is the variable valency. Some metals exhibits or some been found experimentally that some metals exhibit more than one valency, and those metals are called that they are exhibiting variable valency. Means if any element have the more than one valency, like copper has two valency, +1 and +2. Lead, two valencies, +2 and +4. So copper, lead, there are so many other metals, they are called that these metals are exhibiting the variable valency. A reason you will, because valency basically depends upon how many electrons are lost or gained from the outermost shell of the atom. Sometimes these metals, in particular reason, they are losing more electrons than they have in their outermost shell. Means they are losing electrons from their penultimate shells also, and that is why they are showing the variable valency. So, what is variable valency? The metals which exhibit more than one valency, they are called having the variable valency. Next topic is radical, the small one. What do you mean by radical? Radical means if a group of atoms having some charge, either positive or negative, either positive or negative, and they behave as a single entity, they are called the radicals, like NH4+. This is what radical group of atom, not the single atom, nitrogen, but they are not behaving separately, they are working as a one. Ammonium ion, okay, ammonium radical this is, okay, CO3 minus, having the minus charge. What is this? This is the carbonate radical group of atom, but they are working as a single unit. That is, and the radicals always possess a charge, either positive charge or the negative charge. So what are the radicals? If group of atom having some charge, either positive or negative, and retains its own identity, means behaving as a single entity, they are called the radicals. Okay, so children, I hope you understood these are the very basic concepts of chemistry: symbols, formula, valency, and the radical. In my next video, you will see how, by knowing the valency, we can easily generate the formula, write the chemical formula, and then we will proceed to chemical equations and balancing. So thank you so much.